Welcome back everybody, this is Mr. Navarrete, and today I'll be going over recognizing functional groups. So with that, let's get started. For this homework, we're going to be in charge of identifying each of the functional groups present in our molecules. So, for example, in our first one, we have a carbon chain, fully saturated with hydrogens, so we're going to call that an alkane. For the next one, our carbon chain is still fully saturated with hydrogens, except we have the hydroxide group there. So we're going to call this one an alcohol. For our next molecule, our carbon is going to be attached to a halogen, so we're going to call that a halide. Next, we still have our carbon chain. It's still fully saturated with hydrogens, so it would still be an alkane, but to be more specific, since it's all connected to each other in kind of a circle, we can call it a cycloalkane. Our next one, we have a carbon double bonded to an oxygen, but now that one is going to be between two other carbon chains, so we're going to call that one a ketone, specifically for that group. Next, we have one carbon chain on this side, we have another carbon chain on the other side, connected by an oxygen in the middle, so we can call that an ether. Our next carbon chain, we have it double bonded to an oxygen, and now it's also connected to a hydrogen instead of another carbon group. Because of that, we're going to call this one an aldehyde. For the next one, we have a double bond here, so it's not going to be an alkane anymore. We're going to call that one an alkene. Yes, the pronunciation might be a little confusing, so don't worry. It's just going to take some practice. Next one, we have our carbon next to attach to this nitrogen and two hydrogens. Because there are no other chains attached to that nitrogen, we're going to call this one an amine. For 10, we have our carbon chain, and at the end we have this sulfur and this hydrogen, so right off the bat we know that it's going to be a thiol. For 11, this triple bond is the one that sticks out, so we are going to call that one an alkyne. As I mentioned, the pronunciation is going to take practice. Our next one isn't really considered a group, it's just a way that we're going to use to describe this specific carbon. It's going to be double bonded to an oxygen. It has two hydrogens surrounding it. We're going to call this one a carbonyl. Sometimes you'll see it referred to as the carbonyl carbon in longer chains. For the last couple on the front, we have a carbon chain, another carbon chain with an oxygen connecting them in the center. So that's just going to be an ether. The next one is really close, but now the difference is we have a carbon that's going to be double bonded to an oxygen there. So that's no longer an ether. We're going to call those esters. And changing that one up one more time, if we change, instead of having another carbon group, we make it a hydrogen, that's no longer an ester. Now it's going to be a carboxylic acid. For the first ones on the back, we have our carbon attached to this hydroxide, so we're going to call that one an alcohol. Our next carbon chain has two halogens, so another halide. Our next carbon chain does have a double bond, and it also has halogens around it. The two functional groups that are going to be present here are going to be halides, and it's also going to be an alkene. The next one might look a little scary, but it's all just a carbon chain fully saturated with hydrogens, so this one is nothing much but an alkane. For our next one, we have this ring that has this pattern of a double bonded carbon with a single bond, double bond, single, double bonds, and we are going to call this group an aromatic functional group, or you'll also see it as an arene. Our next group, we have a carbon with a triple bond with a nitrogen, so this one will be called a nitrile group. For our next one, what's going to stick out is we do have a nitrogen and a hydrogen, so you might be thinking of calling it an amine, but again, it's just going to be recognizing those groups. Since this carbon is going to be double bonded to an oxygen, it's not going to be an amide, it'll be an amide. For our next one, we have a couple groups. We have our amine on this side, and we also have our carboxylic acid on the other side. Now, a better way to describe the type of group that this is would be as an amino acid. And these are basically going to be the organic compounds that are the building blocks in all life. And that's going to be it. Keep practicing those names. Keep practicing your flashcards. If you have any questions, don't hesitate to ask. We're here to help. But other than that, stay safe, and I'll see y'all next time.